Hey everyone, I am Diana and I would like to introduce my group mates, Sutan and Shoran. We are from tutorial group 1A. Today, we will be discussing with you what is entropy and its effects on the environment and how we can possibly solve these issues. The second law of thermodynamics deals with two separate fundamentals understanding. The first one is about the direction of spontaneous heat flow. For example, we can illustrate that from the classic example of letting a hot cup of coffee cool on the table. The coffee cup cools down due to the spontaneous heat flow from the coffee to the surroundings. This concept of heat dissipation renders every conversion of energy inefficient, due to the fact that the heat is being dissipated into the surroundings. The second fundamental thing to understand about the second law of thermodynamics is about the term called entropy, which is a measurement of the state of disorder. It shows how the entropy of an isolated system always increases. There are many examples to illustrate this. For example, eggs can break, but eggs don't reassemble by themselves, right? Or, if you are carrying a stack of papers and the wind blows, wouldn't you get irritated because the papers fall to the floor? But have you seen the papers flying from the ground back to your hand? Yeah, you'd look like this, or you'd look like Magneto, but less cool. We will be talking about how entropy has affected our environment, and we will be using examples to prove this. We will break our examples into three distinct topics. It can be abbreviated to LAW, which stands for land, air, and water. We will then talk about how entropy has affected the geological processes, the atmospheric processes, and lastly on environmental flow processes. First, we'll be talking about environmental flow processes, which means that we are looking at how the quality and quantity of water and how the marine ecosystem has been affected by entropy. The second law states that as time goes by, things get more disorderly. We liken this to how man has made the world a more disorderly place and has adversely affected the environment in his pursuit of making life more comfortable and more orderly. We aim to explore the irony of this situation. One way which man has made his life more orderly is by discovering electricity, which helps power our homes and our electrical appliances. But have you thought about where electricity actually comes from? One such example is from nuclear power reactors, which are responsible for roughly 11% of the world's power, and is fast becoming a lucrative method to gain electrical energy. Nuclear power revolves around the idea of nuclear fission, which means bombarding a uranium atom with a neutron and splitting the uranium atom into various other elemental atoms, such as barium and cesium, and in the process releasing energy. This process itself is an increase in entropy, as it illustrates one atom splitting up into more atoms. This increases the number of atoms in the system. However, similar to the coffee cup example illustrated earlier, there is waste heat energy produced, and this comes out from the nuclear power station via long wide funnels. Waste energy is released as stacked gases, and these gases are extremely hot, due to the high energy conversion rate by the reactor. Since nuclear reactors require a coolant, nuclear reactors are usually built near water bodies, such as a reservoir. The hot stacked gases are directed back at the cooling water, which is then discharged into the same water body. This results in the detrimental effects on marine ecosystem because the temperature of the surrounding water is raised, affecting organisms such as krill, a type of microprawn.
Whoa, that was a big one. I hate it when that happens.
Hey, Will? Is that you?
Of course it's me. Can't you tell?
No, not if we all look the same.
I don't.
Will, we are krill. We are meant to look the same.
Not me, Bill. There's only one of me in all the world. I am one in a trillion.
Where are you going?
I'm leaving! I want to be free, Bill!
There's no such thing as free will. Come on, less thinking, more swarming.
I'm sick of swarming. We've been swarming all our lives.
Sometimes, Will, it's like you've got a mind of your own.
Tell me, Bill, what lies beyond the swarm?
More swarm.
And then?
Some more swarm.
And then?
Will, there's nothing but swarm. We are a swarm without end.
Everything's got an end. See? I end here.
That is not a happy ending.
It stands to reason, Bill. If I swim against the swarm, I must eventually reach the end of the world. Yeah.
Oh. Will, what are we even looking for?
That's the beauty of it, my friend. I don't know.
Will, please, come back. I fear the worst.
I feared the worst too, Bill, because fearing the best is a complete waste of time. Oh, yeah. There!
Maybe that's a black hole.
They're just myths. Scary talk. Keep us in the swarm.
Coming out of nowhere, swallowing everything in its path.
For something that doesn't exist, it's very impressive. Oh, yes. It's beautiful. So this is all we are. Lunch. To think we spent our whole lives not knowing the truth.
Goodbye, Krill World.
뭐지? Honey, just do it when I'm sitting right here. Man, you're gonna get me hurt.
That's a big difference. Honey?
Research has shown that the reproduction rate of krill significantly decreases when there is a rise in temperature, which happens when the hot stack gases is being discharged from the nuclear power plant. Other than that, corals are also affected by the temperature rise from the hot stack gases, and since both the krills and corals lie at the bottom of the food chain, therefore a decrease in population would mean that the upper trophic levels have less to consume, and this can affect marine ecosystem adversely. Next, we'll be moving on with the idea on how entropy affects the atmospheric cycles. Coal power stations are one of the sources of electricity. Coal has a huge impact on the atmospheric carbon cycle. Similar to the nuclear power plants, stack gases are expelled from the coal power stations, and it contains many harmful substances such as sulfur dioxide and carbon dioxide. Carbon dioxide disrupts the carbon cycle. The ocean and the plants can only take in a certain amount of carbon dioxide from the air. The excess that wasn't taken in traps heat and increases the global temperature. As mentioned before, an increase in temperature can cause a variety of effects on marine life. coal power currently powers 41% of the world power and is a popular source of electricity in countries such as India, China, and Poland. We will move on with our last topic of our project, which deals with geological processes being affected by entropy. In what other ways have humans tried to decrease entropy to make their lives more ordered? Building houses, roads, expressways are some of the examples that we have made our lives more ordered. But people seldom think about the materials that were used into constructing our buildings. Most of these materials are obtained from mining processes. For example, many of you may have seen these beautiful glass houses before. However, glass is obtained from quartz, which is a material that has to be mined from ground in places such as Africa. Even when guys try to decrease their entropy by shaving, did they ever think what was used to make their razors? Razors are commonly made from platinum group metals, PGMs, which is a product of mining and therefore results in entropy increase and have detrimental effects on the environment. We will now talk about how we could possibly solve the issues that we have mentioned earlier, such as the negative effects of entropy on land, air, and water. We will first talk about the issues regarding mining. Since we have learned that mining removes important nutrients from the soil, which then makes them infertile for vegetation. To solve this, we propose a transplant method. Firstly, the contaminated soil will be removed from the mining area. Then, we will proceed to transport it to a treatment plant, and it will be treated via adding lime in order to reduce the acidity of the soil, and also to make it suitable for agriculture again. Then, it can be transported back into the mining area, where crops and trees can be planted over the fertile soil. Additionally, trees also help to fertilize soil because fallen leaves from trees decompose and help transfer nutrients back to the soil. Hence, this method will be extremely useful to re-fertilize our soils. However, one slight disadvantage of this method is that it will be expensive to transport the contaminated soil to and fro the mining area. Next, we shall talk about the solutions to solve water processes, which is regarding the issue on water temperature rising due to the hot stack gases releasing from the nuclear power plants and also the heated water discharged from the reactor. In order to solve this, we researched on whether there are methods for nuclear power plants to function without a nearby water source. One such nuclear reactor that has embraced this method is a nuclear power plant in Arizona. This power plant utilizes treated wastewater as a substitute for coolant, compared to how it uses water from a large body. By using this method, it completely eradicates the need for a nuclear power plant to exist beside a reservoir, which could mean that both nuclear power plants and a healthy marine ecosystem can coexist. This would mean that the cute krill you saw earlier doesn't have to be cooked in boiling water. However, there are disadvantages to this method. One of them is that it is costly to ship the treated wastewater to a nuclear power plant, since nuclear power plants are at remote locations due to safety concerns. Secondly, we have to consider whether the wastewater plant can supply enough treated water to the nuclear plant, since nuclear fission is highly exothermic and would require a lot of coolant. Lastly, we will talk about the solutions to solve the atmospheric processes, mainly how the expulsion of harmful greenhouse gases from coal power plants can be mitigated. Our proposed solution is to utilize substances that can adsorb carbon dioxide and attach it to the funnel of the coal towers. This way, the release of harmful greenhouse gases can be reduced. By using substances such as sodium hydroxide and lithium hydroxide, and by placing them on inner surfaces of the stacked gas funnel, the carbon dioxide release can be binded to these compounds, which greatly reduces the environmental impact of coal power plants. Similarly, if we use activated carbon as a substance, the carbon dioxide would adsorb into the activated carbon, and hence it can be prevented from escaping into the atmosphere. So, let us go through what we have learned so far in the video. We first showed examples of what the second law of thermodynamics meant, and we illustrate that through the coffee cup and egg breaking example. Then, we talk about the negative effects entropy brought about. We talk about the disruption of marine ecosystem through the discharge of nuclear power plants, destruction of land through mining, and also the release of greenhouse gases from coal power stations. After that, we went through the possible solutions to solve each of these problems. But what we need to keep in mind is that although these solutions help mitigate these issues, entropy eventually increases. That's the rule. And in the future, entropy will keep increasing, and sadly, this will bring about the death of the universe. But that will take millions of years to actually happen.